Hello and welcome to another tutorial. So this tutorial is the first part in a short series on making a in-game painting system. So being able to have something in the world that we can just freely paint over the top of. So what we're going to be focusing on in this part is the simple aspect of being able to have a color picker. And so an in-game color picker, and this is something where there might be multiple uses where you have this for other games, so we're going to try and set it up so it can be used in a fairly generic way. So let's dive on in with this. So there's a bunch of different aspects that we need to sort of set up with this, and this is primarily going to be fairly heavily UI based. So what I'm going to do is I'm going to create a UI, and to start with I'm just going to create a panel, and this I'm going to call this our color picker canvas. Now with this I will allow this to I'll use my usual sort of setup. I won't have it world space, but I will scale with screen size, and I'll use 1920 by 1080. Now that canvas, we might end up using it for other things, so I'm going to focus on having most things under this actual panel. So we'll have this as our color picker. And so what I'm going to do is I don't want to have this be stretched. I want this to be a fixed size. And for now, I'm just going to have it be centered. So size-wise for it, let's experiment with what sort of is going to look good. So 600 is probably way too wide. I'd say maybe something around 300. We'll make it so it can scale with size, but we want to keep it a not too large a size. And I think we maybe have it slightly higher than it is wide. So I'm just going to change the background color so it's a darker tint, and we might make that 128, just a little bit darker. So okay, this is going to be our main UI for it. That actually might just be our main canvas. But our color picker is where we're going to have the main stuff. So what we want to do for this and how I'd sort of approach this is I think we support having that color wheel that we often see. So like if we go to this, rather than it being sort of that exterior color wheel, I think doing the version where it's a single color wheel that's controlling hue and also the saturation is, I think, usually a good option there, but we can experiment with a few different things. But the key stuff that I want to add in here is, okay, we're going to add in a panel that is going to be for the actual color wheel. So this is going to be for the wheel. And that will have a raw image under it. So we have that. Now that color wheel image, I will make it fit to the size. And we might end up doing a couple of other changes there with that. But the key thing is we'll have it look like that. And then with our wheel here, we're going to give this an offset of 100 from the bottom. It's because we want this to be an image that's actually sort of square size. So I'll probably actually boost up the buffer here. I think we want to have it a little bit more centered, like that. So that's good. And then what I can do is then also have another panel under that. And this is going to be our component section. So components going to follow a similar pattern. They will have a little bit of text. So we'll bring in the Text Mesh Pro Essentials. And they will also, so components, will make sure that's also anchored down the bottom here. And its anchor position is 0, and we'll make its height 100. So, okay, we've got the text there. We will also add in a slider. This is our component slider, like that. So our text, well, the longest bit of text is probably going to be either saturation or brightness. So let's just compare which one ends up being longer. So brightness is slightly longer, so we'll use that as our actual sort of test text. I want to align that onto the left-hand side. So we just position it like that. The size of that can probably be dropped a fair bit, maybe to 16. It's pretty decent. And then our component slider, well, we're going to make that scale up to sort of fit the area. So we'll adjust those to begin with. The left one needs to get increased a little bit. Probably another 10. That looks pretty good. So, okay. We have the label. So far so good. Component panel, again, we go for the dark background with these. That just makes it a little bit easier for it standing out, which is good. I'll probably adjust these component panels in a moment, because what I want to do is I want to actually have 3 of these. So we're going to add our vertical layout group. So it ends up, being a bunch of things we need to sort of set up here, but it doesn't take too much to get it up and running. We can clean up the alignment here of all of these labels at the same point in time and make sure they're centered. They're already aligned to the left. So that's starting to look pretty good for the layout of this now. So this one will be hue. This one will be saturation. And then this last one is our value. So we'll just update each of these. Hue, saturation, and then we finally have value. Just so that, if we want to have a nice display of those, we can also potentially do some cool things with that. So, okay, we've got our individual color components, we've got the color wheel, so that's looking pretty good for the UI side of this. So now, what I can set up is I'll set up our color wheel, and we're going to create here a folder for our scripts. I won't prefab things yet, but I will shortly. So this looks good. We'll have a script for the UI color picker component. Not that I think there'll be a lot that we're actually doing on this script, but just I think handy to set up so that these all have that script on it, just in case there is further things that we do want to do with this. And then the actual color picker itself, I think good to set up one for the overall color picker. Now the wheel, I could split that out into its own separate one, but it's pretty simple in terms of what it actually needs to do. So there's probably not a great need to actually split it out. But if I'm thinking from a future-proofing point of view, could be useful. So for now, I will actually split that out. We may end up, not really doing much with that, but handy to have it sort of split out for now. So, okay, let's get a couple of bits set up for our color picker one here. So these need to bring in Text Mesh Pro. They are going to have a couple of things linked up to them. So obviously there is the actual label. The reason for this is there might be stuff we actually do with this label at some point. For now, I don't think there's likely to be, but handy to still have no matter what. So then we'll also bring in using Unity Engine UI, because we'll have our slider. That's good. We do want to know when that slider has been changed. So what I will do is I will set up our function to actually receive that message. So we'll have, and it's a pretty simple setup that it actually needs to do with this. On component value changed. Or actually, I'll make this on slider changed. And this is just going to get a new value. What I might also do here, because I think this could be a useful thing to have, is an enum, and we might call this color component. And we'll just have hue, saturation, value. Because this will make it easier for me to have this work in a little bit more of a generic way. So we'll call this component type. I might actually put that first just because it's kind of key. We want this to be able to also let us know when that particular thing has changed potentially. So I'm going to create an event. And this will be a Unity event. It'll provide that color component and a float. And we'll just call this onColorComponent changed. That way, what we can do here is onColorComponent changed, and then we can just actually run that with the new value, and we provide the component type. So we invoke that. So that looks good. That's some of the sort of key bits that we know we'll need. So we'll get that wired up on this so that all of these are properly configured. So this one is hue, we have the label, we have the slider, we make sure the slider, it's got min and maxes configured correctly. We will also link up so that it's feeding the information through. So we can see it's not finding anything that's directly matching, so probably what that means, easy to run into, often forget to just mark something as public. So fix that. Should mean we can now see that setup, so that's good. So we do the same thing with saturation. We just link up all of the bits and pieces. And then largely our setup will be pretty simple. So I never used to go and actually, set up scripts on UI components like of this. I would often just actually handle it in one main script, and I've switched over to doing it sort of this approach of having little subscripts, because I find that it makes it a lot easier if I'm trying to modify it later, and in particular if I'm trying to do more complicated things with it. So okay, we've got our component sliders there. Our color wheel, we haven't done anything with that yet. Just make sure we've got things saved. And our color picker, let's get it set up. So we're going to have a serialize field. We're definitely going to have our color wheel. We'll just call color wheel. We will also have a list of our color picker components. So that's good. And I'll link those up just so that we've got everything tied together. It makes it a lot easier then for all of these things to actually communicate with each other. So the color picker knows about all the little bits and pieces, but it doesn't need to know about, okay, this thing's specifically hue or saturation or value. It just knows, here are the particular ones I've got available. So, okay, let's start looking at just generating that actual sort of wheel texture. So we've got our support here for this, but we haven't actually linked up doing anything with it yet. So this is going to all go into our color wheel. So I'm going to bring in Unity Engine and UI. We're going to need a serialize field for, and this is a raw image. So this is the color wheel image, like that. So that's good. So we want to be able to actually build this texture. We're going to be rebuilding this texture a bunch potentially if things change in terms of size or that. So I want to put it in a generic function. So we'll have a build color wheel texture. And I will run that in start. Potentially could do that in awake as well, but I think start is a reasonable point to actually place it. Now, in terms of what this needs to do, so we need to firstly create a texture 2D. So we want a texture 2D, and this is going to be our wheel texture. So this will be a new texture 2D. Now, in terms of what this looks like, we need to know the size that we're building this for. So that means with our raw image here, I actually want to get the dimensions of it. So our wheel image there, I want to get that wheel image, and I need to get its transform. Now, in particular, in this case, I want its rect transform. So I need to know what the actual size is of this particular bit of UI in the actual world. So this can be a little tricky at times. So I do recommend with this that we actually initially just do a debug log, and we see that if what we're getting out of that is actually a reasonable value. It can be a little tricky with UI at times in Unity getting the size of things. So we'll run that and we'll see what we get in terms of the console. So we've got a null reference because we forgot to link this up. So let's run that again. So we can see we got -40, -40. So that's not an unusual thing to run into with stuff like this, and it's giving us that because we're actually pulling in the margins there, so its size is relative to its parent size. So it gets a little tricky for figuring out what is the exact actual size of this. So what we need to do to get the actual true size of this is a couple of things. Firstly, I need to get the owning canvas for this wheel image. So we have our owning canvas, and I can say color wheel image, and I can do a get component in parent of the canvas. Then what I can do is I can use a rect transform utility, and I can do pixel adjust rect. I give it the color wheel image and the rect transform from that, and then I give that the owning canvas. What this gives us back is this gives us the actual rectangle. So that's a process for us getting that actual rectangle, and if I log out just that, what we'll see is we get something that will actually be correct for the size that we're looking for. So we can see width is 260, height is 260, which is the exact number of pixels of this. So that's good, because that's the bit of information we needed to be able to actually generate this texture. So we can use actual rectangle, and we can go width, actual rectangle, size. Now we could have slightly different sizes here, so what I'm going to do is I'm going to have wheel texture size is our math min, and we provide our width and height. We want the minimum of those, and we also need to do a floor to int on that. So that's going to give us a number of pixels of the actual width of it. So we have our texture size that we can provide here. So we've got the proper size there. In terms of the format, I'm going to use RGB24 because we don't need alpha, and we don't need a map chain for it. So, okay, we've created the texture, so that's good. Now we actually need to build the texture. So what I would say for this is it's pretty straightforward. So we loop through, doesn't really matter whether we're using Y or X as our particular one first, but just for convention, I would normally use Y on the outer loop and then X on the inner loop. So the same sort of thing. Now, we could, in the wheel texture, just directly go and set the pixel. That's entirely an option there. Doing a lot of set pixels like that is slow. So it's something where if we were worried about performance, so if we were rebuilding this a lot, then there would be room there for speeding it up by generating all of these points, stuffing them into an array, and then directly setting the pixels from that. So that is one option of how we can make it faster. And either one is really going to be fine given how infrequently this will run. So what I'll do is I'll implement the set pixel version, but at a later point what we might do is go and convert this to something that is a bit more of a performant version. It's not a critical thing for this, but something we could do in the future. So, okay, what we're going to do is I need to get the vector from the center now. So our vector2, vector from center is a new vector 2, and our x component is our x value minus the wheel texture size divided by, and I do a 2f, so it's doing that as a floating point calculation, just in case it was a odd number. Like in this case, I know it's an even number for the size, but just in case it was an odd number, it just means that it's going to handle that nicely, because this is one part where we do actually want to have it be as precise as possible. So, okay, we might have a maximum radius for this, or a buffer. So I'm going to have an integer here for what we'll call this is wheel buffer in pixels, and we might set that to 5. And what I'm going to then do is have a max distance, and this will be wheel texture size minus our buffer, and we just square that. So we'll call that max distance squared. So that looks good. Just make that consistent. So that's our maximum distance that this can actually go. So what I could do then is, okay, well, if vector from center, and we check our square magnitude, if that is greater than the maximum distance, then we'll set that to 1 color. Otherwise, what I'll do is we'll do like of this. So our wheel texture, for when we're outside, we would do a set pixel, and we'll go X and Y, and we go for setting that to white. Now I am going to rename these, just so I'm being consistent. Cool. So, okay, we know that we're within the wheel part that we should be drawing. So what we can do is we can get the angle of this. So the angle is going to be, and the reason we get the angle is because we can directly translate angle into our hue. So our angle is going to be a mathf, and we want an atan 2 because we want it to fully resolve in all coordinates, all quadrants. So we provide our vector from center y and our vector from center x. So this now gives us our angle. So once we've got our angle, well, that could be negative. So if it is less than 0, then what I want to do is just add to that 2 pi, just to bring it into that 0 to 360 range. Just makes the calculations that we're needing to do a little bit easier. So that means our hue is a mathf, and we'll clamp it from 0 to 1, and it's our angle divided by 2 pi. So that gives us our hue value from a 0 to 1. Then our saturation value comes from wherever we have sort of like how far in, essentially. So our saturation is going to be based upon that distance. So we would have, and what I might do is I might store here distance from center squared, and we'll just work with it like this, just to save a little bit of repeating ourselves with operations. So saturation is the distance from center squared, and we'll go mathf square root. So that's now the actual distance from the center divided by, and what I might do, again, this makes the code just a little bit cleaner, is we'll do that, because then this gets shortened a little bit. And it doesn't cost us anything to set up extra variables like this, and it means that we have code that is more readable, which is always good. So that looks good. Now the saturation, I will, strictly speaking, we shouldn't need to clamp it, but just to be absolutely certain, I will entirely clamp it. So then, all I'm doing is wheel texture, set pixel, again, X and Y, but this time I do a color HSV to RGB. I give it the hue, the saturation, and a value of 1. So that's going to build everything into the texture. We then let it apply all of that. And then, finally, our wheel image, what we do is we set its texture to that. So we've got that being run in start. So what I want to check is I should actually see a color wheel appear now. Let's just confirm that. And so I can see I'm not getting it's not clamping it to sort of the outside like we would expect. So what we want to just check is that we haven't messed up something with our distance checks here. So, and we have messed up. So this shouldn't be our wheel texture size. What this actually should be is our wheel texture size divided by 2. So we're actually generating slightly too large a texture. So we test that again. And now we can see the color wheel that we'd sort of expect there. So, okay, that's looking pretty good there. We want to start getting a few of the bits linked together in terms of, okay, when I click on this, that it actually goes and selects that color. So what I'm going to do is onto the image here, we have our event trigger. Can add a new event type for pointer down. And what I'm going to do is, and I don't have the function set up yet, but I'm going to create a function in the color wheel that what this will be is a public void on color clicked. Now we get a event data with this. So I'm going to need to bring in, using Unity Engine event systems, like that. So on color clicked, and what we get is a base event data, like that. So one of the things that I will do is I'm going to, when we actually build this color wheel texture, these things here are actually quite useful for us to be keeping stored. So I'm going to make it that we have our wheel texture size there. And I'm going to make it that things like our max distance are also up there. And it doesn't hurt to have max distance squared stored up here as well. So I do need to link this up to the wheel. So if I color wheel on clicked, So what we need to do is we need to, with this event data, if that event data is a pointer event data, then we can grab the screen position that was clicked on. So that's going to be screen position, and we can get that by saying, okay, well, let's have our event data as pointer event data, and we don't want just the position there. What I want to do is we can get the pointer current raycast and the screen position from that. But then I need that location transformed into the space for the wheel image, because I've got a screen location, but I need to transform this. So what I could do is I could say, well, my local position is I can take my color wheel image, grab its rect transform, and then I use an inverse transform point. So that transforms a point into a relative location to the origin of the color wheel, which in this case is actually the center point. So that makes things extra easy for me, because then what I can do is I can just see, okay, well, if local position and if its magnitude is greater than the max distance squared, then it's actually completely invalid. And we could do greater than or equal to, but I think we'll go for max distance. So we'll just return, because there's nothing to do. So we're too far out of the actual wheel. Otherwise, what we can do is we can do a similar process to what we did up here. So I'm actually going to grab that code, and rather than it being vector from center, we're working with local position here, and our distance from center squared. What I can do is I'll actually store here distance from center squared, and that is our local position square magnitude. So, okay, we've calculated the hue and saturation. This just saves us having to do a lookup in the actual texture, which I think is good. So, okay, we know that we will have clicked on something. So what I can do, I'll just debug log out for now. So we'll have hue is, and we'll say hue, and we'll have saturation is saturation like that. This will just let us test and make sure that it's actually working. So what I should see is if I click on the outside here, we're getting values and the saturation should go down. And then that's good. And if I click on the outside, we get nothing. So that's excellent. We know now that we have the ability to change the stuff with the sliders. We have the ability for this to have a new color be picked. So what I'm going to do is with this, we'll also set up bringing in a Unity engine events. So we'll have an event here, Unity event. It'll provide 2 floats. And this will be when we have selected something on the color wheel. New color picked. New color picked. Like that. So we can just go down here and say on new color picked, invoke, provide those. So that's good. We've got a lot of the bits and pieces we now need ready for this. So our color picker, well, there's a couple of events we need this to have hooked up to it. So one of the ones is going to be on our color wheel clicked, and that provides new values for the saturation and the hue. Then we know we also have our color component ones changed. So uncolor component changed, and that was our EUI color component. And that was the new value. So that's good. We can start to get all of these bits hooked up. What I would do is in start, well, we could link the, actually I won't bind to these in code. I'll do it via configuring in the inspector. Could do it either way. If I did it in code, then I'd be looking at having to make things a little bit more exposed than I really sort of want them to be. So we'll just set them up via this. All of these three we can hook up at once because they're going to be exactly the same. So we can see everything is linked up there. So that's looking good. So, okay, we can start to now tie all of these bits together. So what I will do is I will have here float current hue, current saturation, and we'll call it value rather than brightness, just so we're maintaining consistency. So what we would do is current hue is new one, update that. So in this case, F the component, if it's hue, then we update that. Otherwise, we can check if it's saturation, and autocomplete is really saving us a lot of time with this, which is handy. So if it's value, so that's good. So we've got all of our interfaces coming through. Those internal values should be updated. We probably want to have this so we can set our initial color. Initial color, or maybe default color, like that. So we've got our default color there. I'm going to default that to white. Then we can go color, and we'll do RGB to HSV. We provide our default color, out, current hue, current saturation, and value. So that's good. We've got those different components coming into that, and we're updating things here. What I will do as a final thing is have here a color updated. And what I am going to do is then have that as a function that gets run when we have clicked on the wheel here, just because there's going to be a lot of different places where we're actually modifying this. So we'll have our color updated. So then I'm going to convert it back from HSV to RGB. So we have our current hue, current saturation, and current value. Going to create here a public color, current color, and we'll make that publicly gettable, privately settable, and we'll just for now set that to white. because that'll actually get updated here. So that's all looking pretty good. I'll put together a Unity engine events just because I want to have here serialize field Unity event color on color changed. So that what we can do is we can then invoke that down here. So that looks good so far. So the main thing now left to do is just to tie all of the pieces together, because we're updating the color, but we want to make sure that that information gets passed on to all of these color picker components. So we want to make sure just everything is properly up to date there with that. So what I'm going to do is, we could hook into that on color changed event, but I think in this case, because we already have the components there, I think I would actually just directly update them. So for component UI in and our components, then what I want to be able to do is just say, okay, component UI set current color, and I want to provide it in a couple of ways. So I'm going to provide both the actual current color as that RGB value, but I'm also going to provide the hue, saturation, and value elements. Reason being is that this way I don't need to go and repeat conversions a bunch of times in case it just makes it a little bit messy if we're having to do extra conversions. So this just keeps it cleaner and neater. And seeing as we've already got the information, we might as well make it a little bit easier on ourselves. So we'll call that in color, float in hue, same thing for the saturation and the value. Now, the key thing here is the value that we use depends upon what our component type is. So if our component type is hue, then what I want to do is, and there's a couple of ways I could approach this. One thing is I could have a separate value to set here. And that's probably going to be the easiest way to work this. And we'll make this that's going to use component slider value. So by default, it won't change. So if it's hue, then value to set is that. So this, I'll actually thin that down. It's very similar for if the component type is saturation. And again, the IntelliSense setup really making our life easy, which I do appreciate. So the thing we don't want to then do is just directly set the value like that. What I want to actually do is go component slider, set value without notify. The reason being, if I just set the value, it would end up invoking this. So you can get that in an infinite loop there with that. So I want to avoid that. So we set the value without notifying. Now the other thing that would be kind of nice to do for this is actually update our little handles on this. So if we take a look at all of these sliders, we have the little handle here, and it would be useful to update the color of that as we've actually gone and messed with stuff. So that's fine, that error will go away once I hit save. So yes, I want to update the color of that sort of slider there. So I'm going to, I don't need to serialize field this. But I'm going to keep track of an image and this is going to be the slider handle image, which I can just retrieve that from component slider, and it already has this handle rect. So I can then, from that handle rec, I can grab a component, and what I'm grabbing is an image. So this is our slider handle image, like that. Because what I will do down here is slider handle image dot color. So that means all of the sliders will tint to the appropriate color. So if we test this out, notice we get an error. And this is one of the cases where the error is actually pretty misleading, because it tells us the error is coming from this line, but it's not exactly that line. It's actually from within this function. And what we'll likely find, so I've put a breakpoint in the start here. I'm going to put a breakpoint in set current color. And then I'm going to run this. And we'll notice, so this runs and it successfully retrieved the handle image. Then this is coming through and running. So starts run for one of the color pickers. And this is coming through and it's trying to set the color. But this image is null because we've only run start on one of the things. Now start's trying to run on the others. So this is one of the dangers with putting stuff in start, is that the order things happen in is very variable. So you also could have implemented this code following along exactly as I have, and you might get a slightly different order. So that is something to be aware of, and one of the tricks, with running, using stuff like of stuff in start. Now the problem is that we've got this separate component here. It is on a completely separate object, so you generally want to be pretty cautious about accessing stuff in something like a wake. So what I would actually do in this case is when we go to set the color and everything down here. So this function does get called during start, but that means a wake has been run on everything, which means it's now safe to refer to other objects. So what I would actually do is if slider handle image is null, then I would attempt to populate it. That's just going to make it a little bit safer and handle if things are loaded out of order. So let's test this. So we get our color wheel and we can see this lines up with what I'd expect. And as I click on different ones, the color changes. And if I adjust things like the saturation, we can see all of those colors there changing. So that's looking really good. So, okay, we know it would be, for that stuff to be updating, that means that our color picker is properly going through this. It would be invoking that onColor changed event. So that's good. Now, it does get seeded with this initial color that we've given it here, and we can test and make sure that works. So let's go for magenta. And we can see that is working correctly. So that's good. So we know it's behaving the way that it should in that regard. Now, although we're not using it at the moment, what I'm going to do is I am going to add in a void. Now we do have a getter and a setter available here for the current color. I could make it that that is exposed and implement this logic in the getter, but I generally prefer to not have properties be that involved if I can. So set new color, and color. So I just want to go through doing it this way. So what I would do is current color is that, and color updated. So that's good. That gives us an interface if we need to, manually override the color. So that's looking pretty good. The one thing that I would like to add to this is I think it would be great to indicate where on the color wheel we are currently at. So what I'm going to do is under this color wheel image, I'm going to create another image, and I'm going to pick a sprite for it, and I'll use their knob one that they have. I'm going to turn it off for being a raycast target, and we can preserve the aspect ratio, let it be the size that it needs to be. So I think that's actually a pretty decent size. Now, in terms of tinting it, I do want to check. Okay, so the center, we can tint it. We can also adjust things like transparency. So that looks pretty good. I might make that not transparent for the moment. And what this is going to be is this is going to be our reticle. So what we can have then on the color wheel, and I'll set this up here. I have a serialize field. We'll make sure we've got the image for it. So the reticle image, and I won't make it a serialized field because we can just directly grab it, but I will keep the rec transform of that reticle. And then in here, reticle transform will be a reticle image, and we get component like that. So that's good. I'm going to link that up now so that we have that properly linked to it. So the idea will be that we can move that reticle around as needed. And I will just reorder this so that the event is last. Makes it a little bit neater for working with. So then when we go and have set a particular color, then what I want to do is I want to position the reticle according to that. So we already have this being able to send out color changes, and we have this event that I want to make the color picker support as well. Sorry, the color wheel. Just because that gives us a single place that we actually do all of this through. So we'll do a similar thing here where the color wheel, set current color, and then I'm just going to grab all of this because it's going to be exactly the same. So, okay. Can do similar thing here where what I will do is set current color, and we'll provide it with, in this case, actually I won't update it there. We'll look at where we want to actually update this. We might set up a function that's just called position reticle or reposition reticle. Or maybe we go for just update reticle. That works. So we provide the hue and the saturation for now. We'll do a similar thing here for updating the reticle when we've gone and clicked. And that won't be in here, it'll just be like that. So trying to have everything running through the same locations where possible keeps things a little bit cleaner and easier for us. So that's good. It'll build the color wheel texture. All of those sort of parts will work when we click. So, okay. Then we can have our update reticle function. So I need to adjust where that reticle is located. And it's not actually too involved for doing that because we've already got the hue and saturation. We're already doing things where we're sort of mapping those relative to everything. And with how we've set this up, that I'm going to switch it like that. Oops, change the wrong thing. Change the reticle, so that's already being positioned at the center, everything like that. So there's nothing fancy that we need to do there. We actually just need to essentially work out the reverse of the calculations we were doing here with these distances. So what I would do is I would say reticle transform, and what we're changing is the anchored position. So that's a new vector 2. And then for the x value, that's going to be the hue that's going to be, so then for the x position, what we do is we take the cosine of our hue multiplied by 2 pi. The y position is going to be based on the sine of that. So we use the sine of that for the y position. And I might put this on a new line here, vector 2, reticle position. That. Let's make that a little bit cleaner and neater again. This ends up being reticle position. Now, that's going to account for the angle for where it is, but we haven't counted for the saturation yet. So what I would do is reticle position times equals, and we have our max distance multiplied by our saturation. So if the saturation is very low, then it's going to bring it in towards the center. If the saturation is very high, it'll push it out towards the edge. So what we should find is when we click on a location, the reticle gets moved to there. And we can see that it does. Now it'd be nice to also update that reticle color to match with that particular color that we're using at that point. So the value we're never actually adjusting in this particular code, which is okay. But what I will do is I want to make it that I can provide the color. So we really only want to do it at this point, actually. So I think the reticle image color gets changed like that. So it should mean we have a few places that clearly indicate the color. So that's just tinting it, and that actually looks pretty decent. I'm kind of happy with how that actually looks, because it's changing as we click, and if we adjust the hue, you can see it cycles around, and that works quite nicely. Same with saturation. Changing the value does darken it, so we do see it change, but we don't need to it doesn't change in position, which is what we would expect. So that's looking pretty good. We've got our color picker working. It's providing those events out. I'm going to actually turn this into a prefab. So I'll have a prefab. And I'll turn that into, I might rename that to UI color picker. So that's great. We have our color picker working. We can, adjust hue, saturation, and value. We can directly go in and click on things on the wheel here, or we can also go and provide in a value, and all of it sort of works nicely for everything, keeps everything else in sync. So that's working nicely, and we just have a single sort of exit point for when that color information comes out. So that means we're really well positioned now for what we'll be doing in the next part of the tutorial, which will be taking this and then using this to tint various brushes so that we can be drawing on a in-world canvas. So not drawing on a UI canvas, but drawing on an in-world canvas. Now with how I've set this up, although I have set this up for in screen space and to scale with that, the way it has been set up, you would be able to easily use this in your world space as well. So that's something that it will work in world space, just might require a couple of tweaks in terms of positioning for things. Thanks folks, hope you found the video interesting and helpful. If you've got any questions, chuck those in a comment below. If there's other things you'd like to see, chuck those in a comment as well. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description below. If you are looking for other ways to support the channel, then I do have a Patreon as well, and there is also a link to that in the description too. But until next time,